Welcome to E-Padasala PG program for computer science students. In this lecture, we will be looking at assembly programming for interrupt handling. In this lecture, we will be discussing about the different interrupts which will be used for serving different purposes, and we will be writing interrupt service programs for external interrupts, and how interrupt based serial communication is run, and at the end we will be discussing about priorities with interrupts. The first one we will be looking at over here is external interrupts. So, in external interrupts, usually when you wanted to make different applications or different products with 8051 controllers, this external interrupts are very useful. So, we have two interrupt pins which is provided for the external interrupts. One is INT 0, another one is INT 1. This has been enabled with associated with the pins P 3.2 and P 3.3, whereas it is pin 12 and pin 13. So, if I am providing a signal at these pins, which in turn invokes the external interrupts. So, here this interrupts is called as INT 0 and INT 1, and this activation signals from outside for this particular external hardware interrupts are categorized into two. One is level triggered, another one is edge triggered. So, when you are looking at level triggered and edge triggered, is the level triggered is one where if I am getting a 0, the whole flat 0, the whole portion when we are looking at, if it is 0, any time it gets fired. But when I am looking at something which is more precision oriented, at that particular instant only it has to be getting fired, then I will say that I need edge triggered interrupt. So, both the things is nothing but I will be providing an input from outside, based on that it has to work. Here I will say that if I am providing a 0, then maybe level triggered, it has been interrupted. If it is 1, it gets the value. But remember that when I am getting a square wave, the whole flat portion of 0 is, I will say that at any time of that particular 0 it gets triggered, but I need to fire at only one instant where it takes from 1 to 0, only from 1 to 0 means only at that particular instant there is a transition occur, that is otherwise called an edge. If I am getting the edge at only one instant, only at that particular instant only the system has to get fired with that interrupt, in the sense I have to go for edge triggered interrupt. So, in level triggered, usually the level triggers, if I am giving a 0, which in turn makes the interrupt service routines, and if I am giving a edge triggered only at the transition side, it gets the interrupt service. So, this is an example code, I mean to utilize the external interrupt service routine to achieve a particular task. So, this is actually assume that the interrupt 1 pin is connected to a switch which is normally high. Whenever it goes low, that means if I am pressing the switch it goes low, it turns on an LED. There is an LED which is connected pin 1.3 and it is normally off. So, an LED connected to pin 1.3 is light, I mean is turned on whenever I am pressing a switch. The particular switch is connected to INT 1 pin. This is the application I wanted to have, and along with that this can be done directly also, but here this application is done through interrupt. Here the additionally what they have given over here is, when it is turned on it should be stay on for certain fraction of second. As long as the switch is pressed low, the LED should stay on. So, as long as the switch is pressed, the LED should on for a fraction of second. That is the application we wanted to make it. So, once the switch is pressed, the LED has to glow. So, now as I told you in the interrupt service routines, usually when I am getting an interrupt INT 1, it will refer the interrupt vector table, and this interrupt external interrupt 1 is available with 0013H in the vector table. So, it comes to this particular location where whatever be the code which is written from there onwards up to RETI which will be serviced as a interrupt service routine for this particular external interrupt 1. So, now just look at over here, we have written over there ORG 00H. So, it starts from the starting location is 00 and LJump main. So, now it says that the main is not start at here onwards, it has to skip to a particular position. It is a long jump to a different location. So, the next locations will be used for some other purpose. Here it will be used for service routine. So, ISR for hardware interrupt INT1 is written at this particular location. So, ORG 001H is written. So, the ORG says that the next location it has to start from 0013. So, there it is written set B P 1.3. So, which in turn makes P 1.3 equal to 1 and move R3 hash 255 DJNZ R3 and it has to loop it. So, what they have made over here is once the service routine is called, then it makes P 1.3 is equal to 1 and it will be retained for a certain duration. That particular duration is accomplished by making R3 is equal to 255. 255 is the maximum value which we can load it with R3 register. Now, DJNZ R3 comma back, what it says over here is R3 is decremented by 1, checks that whether it is 0 or not. If it is not so, it comes to back. So, that way till from 255 to 0 each and every time that many times this particular statement is traced. So, by the time the system is idle. So, up to that particular time this is P 1.3 is equal to 1. So, after 255 is over R3 is 0, it comes down where we clears P 1.3. So, the LED which is connected to P 1.3 is on for the duration where the system is held up in decrementing R3 up from 255 to 0 and then RETA. So, RETA is nothing but it says that the subroutine is over and it comes out. We have to restore the program. So, in the main program, so now when you wanted to run a code, we need to have definitely a main program. So, the main is the tag which where we have written the main program where it has been written from ORG 30H. So, up to this before this 30 we did not touch anything and we have written only service routine in the correct position of 0013H and from 30 onwards we will be writing our main code where main move IE 10001000H. So, when you are looking at this particular one where this one tells you that it is EA is enabled, this one tells you that the interrupt 1 is also enabled. Both the things are enabled first which makes the system can be permitted to use external interrupt 1 service can be utilized and here SJump here. So, now you just look at over there in the main we have permitted we have given the permission and we are making it indefinite loop of here SJump here. So, we have not written any of the code over there, just we made it. In timer we have to start the timer and all those things. Here it is an external interrupt. So, no need to start anything, we have to give only the permission by moving IE is equal to 8 and this is actually 484. So, hash 84 is giving you the permission of EA and INT1 is 1. So, that it gets enabled, that is all. Then we will be just running the main code, that means indefinitely just we will be looping over there. Automatically whenever I am getting a press at interrupt 1 pin which in turn makes this P13 where the LED is connected is lighted and it will be stayed back for certain time, that is from 255 into 1 point something microseconds. So, it will be held up over there, after that it comes over. So, this is the way the external hardware interrupts is programmed to do any work. Not only this work, if I wanted to press a particular, if I am connecting a switch to external interrupt, and if I am pressing it, what has to be done can be written over here, so that I can do any applications with respect to external interrupts, and 8051 can serve to make many of the application products through this particular external interrupts. So, here when you are looking at P 3.2 and 3.3, it looks at normal IO, but INT 0 and INT 1 bits in the IE are enabled, then it will be of different case. So, if IE register is enabled, this will be used as only the external interrupts, otherwise you can use for normal operations also. So, when you are making it IE register enables interrupt, I mean external interrupts, then if I am pressing it, which in turn invokes the ISR routines, and in the ISR routines we can write any of the applications, and at the end we have to make your RETA, which RETA will disables while we are certain hardware pins, which in turn helps us to restore many things of the main applications. So, when you are looking at hardware interrupt, certain things has to be considered also. So, one is when I am getting it from outside as an interrupt, if it is a level triggered, then how much is the duration I need to press it. If it is for only one machine cycle, will it be okay. So, it has been suggested that if I am pressing it for 0, if I am pressing it, then it will provide you a 0. If the 0 is maintained for 4 machine cycles, then it will be easy for us, the system finds it very easy to enable the interrupts. Maybe if it is one cycle, it may miss that particular level trigger. So, because of that, people will provide for 4 machine cycles, that means 4 into 1.085, approximately 1 microsecond this is. So, almost 4 microseconds this has been maintained for lower level, then only the interrupt, I mean interrupt pin, external interrupt is invoked. So, when you are looking at edge triggered, then only at the transition, only it is just like a spike. If I am getting it 1 to 0, then I will be getting a trigger. So, which in turn invokes the interrupt, external interrupt. So, here if I am looking at it is a edge triggered interrupt, it is a special kind. Definitely when you are comparing with the level triggered, edge triggered is much precious. So, if this is the case, the system has to identify, or it has to be informed before itself, the triggering should be done with edge triggering. So, if this is the case, we have to set IT 0 and IT 1 bits of your TCON register, that means TCON 0 and TCON 2. Which in turn IT 0 and IT 1 are the bits. This has to be set, which identifies that the INT 0 and INT 1 are edge triggered interrupts. Otherwise, this will consider, if these 2 bits are not set, then it will consider that it is a level triggered interrupts. So, you just see that along with IE, this TCON is also supports this interrupt service for interrupt enabling and interrupt service. This TCON register also supports. So, you just see that your TF flag, your your TF1 flag and TF0 flags are available over here, which in turn makes you invokes the timer interrupt. And when you are looking at IE 0, IT 0, IE 1 and IT 1, these are the 4 things which will help in external interrupts. I mean the external interrupts will be enhanced, that means the edge triggered has been enhanced with your IT 0 and IT 1 by putting it 1 as edge triggered interrupts. So, when you are looking at, this is a code where the interrupt 1 is connected to a pulse generator, where a program is written where while the falling edge of the pulse will send a high to P 1.3, which is connected to an LED. So, interrupt 1 is nothing but edge triggered one. So, it has been assuming that interrupt 1 is a edge triggered 1, it has been connected to a pulse generator. Whenever I am getting a transition of 1 to 0, then this particular interrupt is getting enabled. So, a program which invokes while falling edge of the pulse will send a high to P 1.3. So, the high is nothing but 1 to P 1.3 where this LED is connected. So, once if I am getting an external interrupt at INT 1 which lights an LED which is connected to pin 1.3. This is the program we wanted to give you, a sample program for making external interrupt enabled task. So, here you just as usual org00 is there, your main program is not written immediately, ljump main is given over there. So, the system identifies that main is written somewhere at the longer distance. So, at 0013H, that means it is interrupt 1 where set B P 1.3, once it has been invoked then it will come over there. The pin is set, the LED pin which is connected P 1.3 is 1 and we have retained there for 255 clock cycles has to be counted, then it clears. So, this is the same thing which we have done already, but only thing is we wanted to find out that this will be invoked only when the edge triggering, that means the falling one, whenever I am getting a falling edge then only it has to happen. So, the difference in the main program is we started as usual, the main program is in 30H where main set B tcon 0.2, that means that in the tcon register the bit 2 is set, which in turn takes that, which in turn tells the system that the INT 1 is edge triggered interrupt. Whenever I am getting a edge, that means falling edge, then only it has to get triggered. And I will be moving my interrupt enabled register as usual EA and INT 1 is 1. So, that which permits me to invoke the external interrupt, and there is a end. The loop is getting, in the main we have we have set, that is all. After that we will be putting an indefinite loop. So, the system itself takes care about this particular ISR. Whenever I am pressing, there is a switch where we pressed in the previous program. In this program there is a pulse generator is connected. So, in the pulse whenever I am getting a falling edge which is 1 to 0, by the time it gets invoked, there LED is given a 1 and maintained for certain time, after that it has been switched off. So, this is the way your external interrupt has been used to get the LED has to glow at a precision oriented time. It is just like any of the thing which we wanted to do it at a precision oriented time, not for any time within that particular level of 1 or level of 0. So, that way we will be going ahead when you are looking at external interrupts with respect to edge triggered interrupt. So, when you are looking at serial communication, the next is your serial communication. So, when you are looking at already we have gone through the previous lectures the serial communication, but what we have done over here there is we have written the code on checking up TI-RI and many things based on that we have done. But here in the serial communication the interrupt has been raised if I am getting either TI or RI. So, once the TI or RI bit is set, when it will be set is when either if I am sending a data serially, if I am getting a stop bit then TI flag is set. Maybe during the receiving, if I am receiving a data from outside, when I am receiving a stop bit, the SBUF will receive the whole data set, so that the RI is set. So, this transfer interrupt and received interrupt. So, these two interrupts which in turn makes the serial communication properly, and this has been used for providing the interrupt service routine for serial communication. So, you just see that in 8051 TI and RI is connected together and it is odd, we will be giving you the interrupt service, because for the serial communication we have only one pin is given over there. So, because only one particular in the vector table you know very well, it has been provided for serial communication only one service. So, because of that, if either I am getting a TI or I am getting an RI, I need to provide that particular interrupt service. Usually while we are receiving it, we need to definitely look at this particular serial communication interrupt very seriously. If it is transmitting, because we will be sending, so at any time we can send it. So, the receiving of serial data is given a much importance when you are comparing to transmitting a serial data. So, when you are looking at a code which helps us to understand the serial communication properly using your interrupt service routine. So, here just see that the org 0 as it is ljump main. So, the whole thing, I mean the code is not written at the immediately, and we will be going ahead with org 23. So, 23 is serial communication interrupt service routine is written. So, this has been referred through your vector table. From the interrupt vector table, the 23 is the address where we are writing the service routine over there. So, first ljump serial is there. So, org 30, I mean the serial is the code which we wanted to write it when you are looking at the serial communication has to be invoked, and this is your main program where org 30h, where from 30h onwards I will be writing my main program. Here you just see that because we have given a program where write a program in which 8051 gets data from port 1 and send it to P2 continuously. I have read when a data from P1 and it has been directed to P2 continuously, while the incoming data from the serial port is sent to P0. So, whatever be the data I am reading it from the serial port is parallelly sent to P0, and the parallel data which is read from P1 is sent to P2. So, that is the code we wanted to write it. So, P1 read the data from P1, send it to P2, you can write it in main, and the serial port you read the data through interrupt and it will be sent to P0. And if I am looking at serial communication, then I need to know that what is the baud rate with which I can send this particular data or receive the data. So, here it has been given 9600, because the baud rate has to be set, I need to look at what is the oscillator also. So, if it is 9600 as the baud rate, I know very well I need to set FD in my TH1. So, in the main first I made it P1 is 0 FF. So, which makes that it is a input port. T mod is 20H, that means timer 1 mode 2 is made, because we wanted to have timer has to be auto reload. So, that we wanted to set my baud rate also. So, TH1 is set as 0FDH, this we have gone through. If it is a baud rate is 9600, then the TH1 is set with FD, this we have gone in the previous lectures, and the SCON, now the serial communication register also has to be set. Remember that for serial communication we have to set many things, T mod has to be set, TH has to be set to maintain the baud rate, and the serial communication has to be invoked by setting up the serial communication port SCON as 50H, and IE is now this has been achieved through the interrupt enable register. So, because of that EA and the serial communication bit is set and all other things are zeros. So, it is actually 90 is set. So, 90 makes EA 1 and serial communication as 1, interrupt is 1. So, now we will start the timer, because we wanted to make the system has to send one character once in 4 FD is nothing but 4 clock cycles. So, because of that we need to start the timer. Each and every time I am getting a overflow, I will be sending one character, that has been done internally, and now once I started the timer, then the program will takes care about sending the data continuously. I need not look at what happens inside it. This is the one which written in the main, because we have been given read the data series parallel data from P1 and send it to P2 continuously. So, because of that particular reason I have read the data P1, send it to a accumulator, then move P2 to A. So, P1 read move A comma P1 makes P1 is read and send it to A. Now, move P2 comma A makes A, whatever be the content of A is sent to your P2 and sjump back. So, now this has been put in a indefinite loop. So, that whatever be the data which is read from P1 is sent to P2. The main part is nothing but your in the serial communication interrupt service routine. So, this has been written in this particular serial. So, here we made it the serial communication interrupt service routine is written with 100H. So, serial JB. So, what we have written over there in this particular address, the service routine is started and writing over there. So, here first we will be checking whether it is TI or RI, as we know that we have only one interrupt, either it is TI, it may be RI. So, we need to check whether it is TI or RI. So, we have to check JB TI trans. So, if T A is equal to 1, then it comes over here. That means what? We have sent the whole data from SBUF, that is what it indicates. Once the SBUF is sent all the data to outside, then it sets T A. So, once T A has come, we identify that the whole thing is set. Now, we need to clear this T A, so that the system will send the next set of data. So, now if JB T I, then it comes over here, clear T I and RETA. So, this is for transmission of data in serial communication. Maybe if it is reception of data in serial communication, then JBTI fails, because we received only RI. So, it comes down. So, once RI has received, RI is set, then what it means is the serial buffer SBUF received the whole data, it has made the data into a word. Now, this has been assigned to A, move P naught comma A makes whatever be the content of your A is sent to P naught, and because we have read the data completely SBUF to A and A to P naught, now we have to clear your RI. So, that only the system will go for the next serial communication. So, clear RI and RETA. So, for whether we will be getting a RI or TI, the whole process is invoked. If it is TI, it does this, it traces these two things. If it is RI, it traces all these things. So, that if I am getting either serial communication as reception or transmission, this particular interrupt is invoked and it has done this. If TI is set or RI is set, this particular one is invoked and it has done this particular job. This is the way the serial communication has been established with your interrupt. So, now when you are looking at the 8051 with your interrupt, these are the flag bits which will be very, very important. So, IE0, IE1, TF0, TF1, serial port means T1 and timer 2 is TF2. So, this is actually for these two things are for 8952, these are for 8051. So, these are the flags which will be very, very important. And SCON register, RITI flags, TCON register, all these interrupt flags. So, these are the flags are very important. Sometimes this has to be cleared by us like TI and RI, the TF0 and all these things which will be cleared by the hardware itself. So, when you are looking at this kind of interrupt, as we told already with 8051, if interrupt is requested by the system has to identify which has to be served. If at a time 2 persons is calling, 2 persons is requesting for interrupt, then the system has to know that which has to be served. So, if this is the case, then we need to set the priority. So, the system has either it has to serve or it can omit. So, now when you are looking at the priorities, we will be having one particular table which is nothing but priority table, where this is the order with which it has been arranged. The external interrupt 0, external timer interrupt 0, external interrupt 1, timer interrupt 1, serial communication, then timer 2. This is for only 8052. So, this is the order with which the highest to lower priority has been given for 8051. But if we need to change the priorities based on our applications, that can be done also. It is possible to do, change the priorities also. See, if I am looking at that IE0, TF0, IE1, TF1, this is the way it gets. This is the highest priority, this is your lowest priority. If I wanted to set it the other way around, I wanted to have something to be given first priority, something to be given the next priority, then I can have this interrupt priority register, where I can set, if I am setting a bit 1, then that has been assigned a higher priority, and if I am setting a bit 0, then it can be given a lower priority. So, when you are looking up these register, the timer 2 and timer 1 and external interrupt, and these bits if I am setting 1, then it identifies that that has been given a high priority and all other things is given a lower priority. Sometimes we can set two pins as 1, then in this order which will be the first, which will be the second, that also can be taken care. So, that has been done. See, this is actually the interrupt control system, where all these things are connected. if we need, if it has been connected, then this particular interrupt control is serviced. If it is not connected, then this will not be given the service. That is the idea behind IE register. So, if I am putting a 1, then it gets shorted, so that this will be permitted. If I am putting a 1, this shorted, then this particular interrupt can be permitted. So, that is the way the register controls whether this particular interrupts has been permitted or not, and the highest priority and lowest priority has been assigned by connecting it in this particular layer. So, this is a hardware setup which tells you what we have covered in the previous slides. So, when you are looking at this is an example, if I am making it, I mean INT 0, IF1, TF1 and INT 1 all are activated at the same time, what way it can be given the priority. So, as we know that the table says that IE is given the first priority, IE 2 is given the second priority, and TF 1 is given the next priority. So, that is the way only it will go. So, in this lecture we have gone through different interrupts which are all serviced by 8051, and we have written code to handle these interrupts. And when you are looking at external hardware interrupt, it can be invoked through level triggered as well as edge triggered, that also we have handled with different assembly programs. And the serial communication is slightly a tougher one, which can be made very easy with writing an interrupt based serial communication program, that also we have gone through. And not only that, we have different priorities with your interrupt, how it can be set, that also we have discussed in this particular lecture. So, all these things you can refer with 8051 microcontroller and embedded systems using assembly and C with the Mazdi book. Thank you.